for data ingestion, because you can see how nice it is, right? All the fast data transfer. Okay, please go to forourson.com/passion and download. There is a very big file. I think you should download it into your virtual machine. Because it is containing PowerPoint, I am downloading it into local as well. So I'm going to do it two times. One is for the virtual machine and one is for the local. You can do it for the virtual machine, and it contains the PowerPoint that I'm going to take today, and that you can extract and move it to your local machine. So forourson.com/passion, and please click on machinelearning.zip. It's a big file. It's about 1.4 gigabytes. Oh, no space. Remove that latest Ravishankar movie. How are you sitting patiently? Australia batting, right?
Watched 10 hours last time.
Any wicket gone?
For
Australia?
9 wickets. No, not for Australia. I think
No need to look. I just asked only.
But India lost that game, third game, or second game,
third.
third
Machine
one.
learning.
Machine learning.
Machinelearning.zip. So this is a topic that I have taken some time back for a big talk. So it's very exhaustive. You don't have to know each and everything. I'm just giving you a fundamental idea. This is not related with big data and Hadoop that you have done, but this is how machine learning works, just the fundamentals, in order to make sure that, okay, you know what is happening in machine learning and what is the difference, etc., etc. So that's the only purpose of this. If you want to go in detail, of course, statistics, data science, machine learning, mathematics, that will all come into picture. Okay, what is the definition of probability? So that is where it starts. So you can understand now, right? So that is the fundamental idea of what are De Morgan's laws? Bayes theorem. Okay, so those are the fundamentals that are needed. That's why I told you this is a completely different thing. So just for the information you need, you do it. If you want to go and excel into this, you have to do that statistics very nicely. And you should know fundamentally what is vector algebra, what is meant by a vector, what is meant by a tensor. All these kind of things you will need to know if you want to go in detail about this. Okay, but it's a very interesting area. Why? Because it's the highest paid. That is number one. Highest paid in the sense that the salary itself starts about 200K per year. That is how the field is, right? Because this will drive the company's revenue. This will identify and make sure that you know what are the problems and how can you improve the business. Working with the business, you will be able to improve the way in which the income is coming in, etc., etc. That's the advantage of machine learning if it is properly used, right?
What you talking about data science?
Yeah, data science, right? Data science purely on the basis of these probabilities and you know the data statistics and those kind of things, right? Usually in the companies, this will be masters and PhDs working with many different tools, and main language that they use is Python. Okay, because It is very easy to use. That is number one. Second is that there are so many libraries available in Python which helps machine learning. Right? So mostly the language used is Python, but currently you can use Scala, Java, you can use Spark, MLlib, all these kind of things you can use for advanced machine learning things. So what you need to do is just unzip that one. Okay, before you're unzipping it, let me just open the PowerPoint and we'll go through the slides and then we will continue. Okay, so I think it is not downloaded yet. It will take a while. It's a very big file. Okay, and then just open that PowerPoint presentation, right? You can skip some 10-15 slides in the initial slides because that tells about history of computer science, how computer science evolved, etc., that we can skip and we can directly go to the machine learning fundamentals. Okay, so before starting, just think about this. Okay, so I have a number. This is x and this is y. Okay, and you might have learned this type of things in schools a lot. So assume that I have a number here and I am writing here 11 and I have another number here and I am writing here 19. I have another number here and I am writing here 28. Now I am asking you, what should I write for 7? Can you please answer that? Yeah. Think. It's very simple. It's a school question. Your child will be able to do.
39?
No.
No, 4. So I think 53.
No, not 53. Think again.
54 many and 1. So
What is the answer?
B, 6. 49 into 4.
You are very close. How you got 49 and then you add what the number you need to add? You just find out.
Actually 2 and then
Find the square and add 3. So
Yeah.
3 into 3, 9. 9 plus 3 is 12.
Yeah.
4 into 4, 16 plus 3, 19.
Yeah.
5 into 5, 25 plus 3, 28. So 7 into 7 is 49. 49 plus 3 is 52. Okay. Now please tell me, what did you do?
Pattern recognition.
Please tell me, what did you do to get this answer? Tell me what happened in your brain to get this answer.
I just found a pattern, like 3, 12.
You looked at the existing data. You looked at the output. You looked at the input. You tried to find out a relation by taking more data. Once you felt that there is something you found out, then you tried to apply that and saw whether it is working or not. For example, 3 into 3, 9, 9 plus 3 is 12, 4 into 4, 16 plus 3 is 19. Then you will see, okay, 5 into 5 is 25 plus 3. Is it 28? Yeah, it is 28. Then I ask you a question, what is the answer for 7? Then you may say 7 into 7, 49 plus 3 is 52. What you did is an impressive thing in mathematics, which nobody has found out till now an answer. What is that? You know very well that if I am telling you y equal to x plus 2 and if I am giving you x equal to 5, you will immediately tell me what is the value of y. If x equal to 10, you will tell me what is the value of y. Right? I am going to tell you that y is a function of x. Y is a function of x. In our case, x plus 2 is a function, right? I am telling you to find out what is the function, not x and y. X and y I will give you. X and Y I gave you. I'm telling you how you got this answer, and that is machine learning. This is the best definition of machine learning. Finding a function for a given input X and Y. Once you know that function, then when a new input is coming in, you will apply that function and will find out the answer. Normally, in the machine learning world, it is not the word function which is being used. We will use, you created a model. So in machine learning, you will create a model. How will you create a model? From the existing data, you will create a model. Then you will apply that model to the number and you get that output. For example, what is the model by which you will accept a credit card or not? By looking at the history of the data of all the people like you, I create a model. For those who do not want to get into the very details of what is a model, just consider model as an exe file in Windows, which is created from large amount of data. And how is that model created? The model is created by making the machine learn. How will the machine learn? It will look at the history of the data. Why Facebook is able to predict what will be your behavior? Why? Because by looking at all your profiles, by looking at all your history, by looking at integration with the WhatsApp, they know what are your likes, what are your preferences, what are the favorite locations you like, etc. And if suppose a travel agent is asking Facebook that what should I propose to Vasu or Shashi, then it will look at your history, the model, and then it will tell that more likely they will be liking this. So this is what controls machine learning. Finding the function out of your input and output. And please understand the magic, okay? I wanted to do something on this. If I know this X and Y and if I am able to find out that function in a mathematical manner, then I don't need your ab initio. I don't need any ETL tool. Why? In ETL, what are you doing? You have an input data from the database and you are applying a function and you are converting it into another form. That particular one, if I am able to do automatically, then I have found out the world's first auto mapping tool, which means that I don't have to do anything at all. Similarly, for your data quality exercises and all, assume that you have got some 1 million rows and already there is quality data on the left hand side and you understood that how the data quality function is being implemented internally rather than you writing, and automatically let the tool find out that okay, in this particular context, for this particular data, this particular field, this is the function which will create a quality data, and automatically it will find it out. There is no such tool in the world today which is allowing you to do auto mapping, and if we are doing one, that will be the world's best invention that can happen in the world of data. The reason is that if suppose you have it, you can replace your ETL tools, you can replace your data quality tools, you can replace your machine modeling tools. You already implemented something very advanced in artificial intelligence, because it is looking at the input, looking at the output, and then finding out how I can reach the output. And be careful, 3 to 12 can come in 10 different ways. For example, 3 plus 10 minus 1 is 12. So, when you are looking at an input and output, there can be many possibilities. Out of that, how will you decide which possibility that you want? That is the biggest challenge. How? You will look at the data, and that is why data is most important in machine learning. The more data that you have, more trained the model would be and more accurate the prediction would be. And the way in which you find out that particular answer is called a predictive modeling or prescriptive modeling. And when you are doing that, you will get that correct answer. Then you found out the model which works. And what the data scientist and everybody will do, assume that for Citibank or for Bank of America, they wanted to find out whether a credit card promotion in the month of March, would it be profitable or not? They will look at all the previous data of all the previous countries, of all the previous populations across the globe. They will find out where and all the promotion was being done and were successful. Depending upon that, they are going to give a promotion for Jacksonville, and then they will tell that, okay, my model says that this particular promotion in Jacksonville in the month of March would be profitable. Now, when the data scientist is deciding that, they may have incorporated so many variables to decide it. For example, one variable is Jacksonville population middle class or low class or high class? If it is very, very low class in that particular locality, there is no point in giving a promotion. So low class, high class, middle class, the balance of the family or the richness of the family is one factor. Second factor, is there a lot of shopping malls near the area where this particular promotion is going to be established? That is a second variable. Third variable may be like, is that a vacation time where all the people will be going outside so that nobody will be spending money in Jacksonville? That may be a third criteria. Sometimes the data scientist will add a variable, remove a variable, add some more variables, adjust the variable. That is a work of data science. And if the data scientist is finally able to tell that, okay, that promotion is going to be successful, and promotion became successful, and that increases his ability of prediction, and the model becomes more and more solid. So it is an evolving area. Every day it will learn. Okay, now in Jacksonville that promotion became successful. What will happen internally? Internally, that data, whether it is successful or not, will be added to the model for the next prediction. So the model is learning like a child. And in artificial intelligence, these models which are being intercepted internally, which are being learned internally, they are called neurons. This word is taken from biology. Neuron is what make you think. And they will create these neurons. There are positrons, neurons, all these kind of things in artificial intelligence. This will come in deep learning. So in machine learning, there are two areas. One is the normal machine learning and another is deep learning. What is the difference? If suppose I am showing you a figure, and if suppose you are telling that out of this cat and out of that fish and out of that monkey, it is telling cat or fish or monkey. That is machine learning, identifying the picture. Okay. In deep learning, it will go more deeper. It will identify not only that it is a cat, it will tell you which species of cat it is. It will go so deep, and that's the word deep learning. Right? So, these are all some of the fundamental ideas, right? And it is an exciting, very nice field. You can see that slide in the machinelearning.zip folder, which I told you to download. And you can go through the history whenever you are getting the time, okay? I'm talking about Alan Turing, some of the inventions that happened in the in that particular time frame, etc., etc. You can go through. And so you'll see those things, and then let us just go to some of the fundamental ideas that I told you already, that very strong mathematics is the fundamental idea behind it. If you don't know these things, you are a little bit lost. Okay, these are all the schools and colleges things. Okay, and De Morgan's law says that union of an intersection equal to intersection of the unions, and intersection of a union equal to union of the intersections. And then there are some great persons came in those areas, all history, how computer evolved, etc. So this is a talk, as I mentioned to you, in one of the forums that I gave on bringing machine learning into structure. And here is where the first slide starts. So in machine learning, as you can see, just fix this. Machine learning talks about input and output. Then, machine learning also talks about the input, the output, and as I mentioned to you, your work is to find out the function that is needed for machine learning. The charge is over. Yeah. Right. So you have an input, you have an output, and you find out what is the function that is required. And if it is successful, the output again will become the input. That is the great factor about machine learning, that every time when a prediction is being made, that prediction is considered to be a learning. It is like, assume that your child plays chess, for example. If I take my example. And in the chess, when he is playing, or he or she is playing, at the time they found out a new move. They might have failed at that particular time, but they will learn, okay, if this comes, this is a move. So they take that as the input for the next game, correct? Exactly that is what is happening in the machine learning as well, right? So there are so many examples. Don't worry about all these things. In machine learning, there is classification and there is prediction. What is the difference? Classification. Do you get in your email or Gmail spam folder? Is a beautiful example of classification. Google does classification of your emails and classify it as whether primary, secondary, social, promotions, spam.
We use labeling right, in the
Correct.
classification.
In the classification, you will use a lot of labeling examples. Prediction, I have given you many examples where you will predict whether this person is likely to buy or not. Right? The first algorithm that I want to discuss is called a decision tree. Very, very nice. One of the very powerful algorithm which I am also using now for the claims example that I told you yesterday. So what's a decision tree? Just to know this particular one, how to use it, at least you know what it is. Okay, let's take an example. Where is this data? Oh, that font has gone and the data is not there. Okay, look at this data. View, zoom in. View. Can you see? Yeah. Look at this data. I have got some basketball statistics. This is the result of some games that happened across different places, and we have got the statistics. Whenever there is a game in the home means Jacksonville, away means away from Jacksonville, right? And when the game is 7 p.m., Fred is a very good player in the Jacksonville team, let's say. When Fred started it, and Joe's offense is center, Joe's defense is forward, opponent team or opponent component is tall, and the result was 1. Okay, so I recorded that result. Are you getting it? Like that, I have got a lot of data, and this data is recorded. Now think very carefully where you can apply all these things. Bank, credit card, whether Bibin received the credit, I have accepted the credit card offer, Shashi accepted the credit card, Krishna accepted the credit card or not, all the data. Claims rejected, yes, or accepted, no, depending upon so many variables. MRI scan, this scan, that scan, and then all the data is there, and I have loaded all that data, and then finally I will told, okay, accepted, or next one, denied. I create the history, and we have got lots and lots of data to create that file, correct? So we have this particular file, okay? And now, once you come to this file, One question to you. I have that all file. Tomorrow, a game is going to happen. And it is not going to happen in Jacksonville. It's away. It's at 9 p.m., not at 7. Fred is not starting. Blah, 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 blah. What will be the result? That's a classic issue. How will you find out?
You tell the probability.
So tomorrow when the claim comes, whether the claim will be rejected or not. Tomorrow when the credit card offer is being made, will the person be accepting or not?
Depending upon the variables, we calculate the probability.
You cannot calculate the probability in that case. Why? Because probability is out of out of n things, if m possibilities are there, probability is defined as probability m by n. And probability can never be greater than or equal to 1. Right? You can create probability A given B, etc., etc. But if suppose you have 100 variables like this, how are you going to create that probability theory? Because I cannot say A given B. For example, when the game is away and when the game is 9 o'clock, like that, how much combinations I will have to create?
Yeah, so different
Very, very difficult.
numerous combinations.
Right? So look at the problem. And this is what the world is doing. Right? What are the problems? Why are you not able to analyze the result? Okay, you look at the data. You will tell that, okay, I will start with this particular data. Is Joe's defense center or not? Tell me an answer, yes or no. Okay, if it is yes, is the game happening at 7 p.m. or 9 p.m.? You will tell yes or no. Yes, is the game happening at home or away? You will tell yes or no. If so, you understand that so many if conditions. But where did I start? What was my starting question? Joseph. How did I get that starting question? Why can't I start here?
You prioritize the variables that you're using. You prioritize the variables.
How? There is trillion rows in my data. So, the challenge is where to start? What is my route? Why route? It's a tree, right? One question to answer yes or no, answer another yes or no, answer, right?
So for calculate win for all the homes, win for all the centers, win for all the win and lose for all the variables.
Okay, so let us assume that Mahesh, you got 100 wins for center. You got 100 wins for other one. Now again center is coming. Will it be a win or lose? How will you tell?
Yeah.
Are you not getting the question?
I get it. Yeah.
So even if I have 1 million rows in which 500,000 is saying that Fred started, I won. When Fred did not start, I lost. Now the data is Fred is coming. Will you answer yes or no? Next question is, after Fred started, which node I have to go? Which question? Is it played in home or away? Is the opponent is tall or short? Is it happening at 7 p.m. or 9 p.m.? Where should I go? That's the next one. Third, by one question will you be able to, for example, if Virat Kohli is batting, India is winning. That is finished. Okay, maybe. Correct? One question. Where to start? How long you will go? Predict 10. One of the best example is, will Mahesh be playing cricket next week? Ready? Take the history of the data. When the weather is good, when there is Saturday, when we are putting the class 8 o'clock, which is very important, Mahesh will not come. Prediction.
I was waiting for you to bring that cricket.
Right. Yeah, I have prediction.
Will we win? What would be the outcome?
It's $1 million.
See another machine. Yesterday, Donut, very happy. No, today not even there. He is the one who proposed that today class should be there. Machine learning, prediction. Right? Friday, no, tomorrow. Let us take the class. So, where to go? This is very interesting. A applying machine learning to your daily questions. Okay. So,
Difficult.
lot of mathematics is there. First of all, you should know two words: information gain and entropy. I'll tell you what is entropy, just for your understanding. Entropy. Remember enthalpy and entropy we studied in physics. What is entropy? So assume that in this particular forum, I am asking who sings songs very well. Let's say you will give some equal probability to maybe everybody because we don't know who will sing the song very well, right? But assume that okay, Vasavi is singing very well. You came to know that in one program you have seen that Vasavi is singing very well. Next week, if I am asking who sings well, everybody will tell it is Vasavi. The entropy became high. Entropy is the certainty. Okay. Who plays cricket? You know the entropy is very high for somebody, right? So entropy is the certainty. Similarly, there is information gain, and everything is the gain is calculated using big mathematical formulas where you will calculate entropy, you will calculate all these kind of calculations, and then you will do it. What is that symbol, Krishna? Huh? Sigma. Sigma, correct? You say sum of in here, or you say sigma? Okay. And what is the meaning of this? Correct? It's modulus. And what is the meaning of this?
From range.
If y equal to x square, what is the derivative of y? Y equal to x square, what is the derivative of dy by dx? It is 2x. Y equal to x square, how the graph will be? It will be a parabola. 2x, how the graph will be? What is this straight line you got? It is a tangent which touches the parabola. So if you have lots and lots of data and you want to recognize an image out of all your images, this is a cat, this is another cat, this is another cat, this is a fish, this is a fish, and I want to calculate whether the cat is this one is a cat or not from this particular one. What you will do? You will create this particular graph and then you will find out the tangent which is coming very close with this particular picture. That is how image recognition is done in machine learning. Derivatives, full calculus. Tangent is always, remember, is very much related with machine learning. Why? Because out of all your data which is dispersed and distributed, a tangent gives the point where the touch is happening. And the touch is the answer to your question. Okay? So, those formulas and all are there, but you don't have to bother all these things, right? So, what we are going to do is, we will do a decision tree, and I want you to do, so I am going to pause this video here. How will I do that? Option and then